we've got three sections that we're going to deal with. Everything deals with triangles and finding either missing angles or sides. Now, today everything will be right triangle trig, so it's going to go back to what we did back in chapter 4. So it's a lot of like opposite over adjacent, adjacent over hypotenuse, opposite over hypotenuse, okay, and the main trig functions. What we'll get to is tomorrow we'll talk about like law of sines for 2 days, and then law of cosines, okay, in terms of trying to find missing angles and missing sides of either, in some cases, right triangles, in some cases, just general triangles, okay, that doesn't have to be a right triangle. So remember whenever we had a right triangle that you had the acronym of SOHCAHTOA, where it was sine over, where sine was opposite over hypotenuse, cosine was adjacent over hypotenuse, and then tangent was opposite over adjacent. Now, again, whenever we dealt with sine and cosine and tangent, we were accustomed to x over r, y over r, x or y over x, things like that, whenever we were dealing with just the angles. Whenever we deal with the triangles, that's whenever it becomes opposite, adjacent, and hypotenuse. Okay, whenever we talk about the opposite side, that is the angle that is going to be the side that is going to be across from whatever angle. So whenever we're dealing with certain values, okay, if I have 34.5 degrees, every side, depending on where the angle is, it's going to be dependent on if it's opposite or adjacent. The one angle that's never going to change is going to be the hypotenuse, which will always be across from the right angle. Okay, so in this case, the C side is the hypotenuse. Okay, with this triangle, we are trying to find side A and side C. Okay, you're always going to be given at least two parts. You should be always given an angle and at least one side. Whenever we find side lengths, okay, if you find two of the three, you could do Pythagorean theorem, but I want to stay away from using Pythagorean theorem because I want to use the side lengths that they give me. Okay, because what's going to happen is we're going to have to round values, and I don't want to use Pythagorean theorem with values that I had to round. Okay, so always use your trig functions that we have up here as terms of sine, cosine, and tangent. So if I found my hypotenuse, I have side A and I have side B. Now, I'm not particularly fond of using A, B, and C because one of the letters we're accustomed to using with cosine is adjacent or even with tangent. And the reason why I don't like using A, B, and C is because whenever we do that, students automatically think that that should be the adjacent side. Okay? That's not the case here. Remember, the opposite side is the side that's opposite of the angle. So if 34.5 is my angle, then A is actually my opposite side. The adjacent side is always going to be the side that makes up the angle. So down here, 10.5 is adjacent. So I need to find the opposite side and the hypotenuse, okay, using the angle that I'm given, 34.5 degrees, and 10.5 in terms of my side, my adjacent side. It does not matter to me which one you solve first. Okay? If you want to solve the one for the hypotenuse first, go for it. If you want to solve the opposite side first, go for it. You're going to have to solve all of them some way, somehow. Okay? So whenever I do this, whenever I set this up, if I'm just going to go with the opposite side. Okay? So I'm going to do here using 34.5 and 10.5. So which trig function am I going to use for the opposite and the adjacent side? Am I going to use sine, cosine, or tangent? I'm going to use tangent. So I'm going to have tangent of 34.5 degrees equal to opposite, which is A, over adjacent, which is 10.5. I need to solve for A. So I need to get A by itself. So what do I need to do to both sides to get A by itself? Multiply by 10.5. So then I'm going to have 10.5 times tangent of 34.5 degrees is equal to A. Going to my calculator, whether it be the graphing calculator, scientific calculator, whatever, okay, and I just have to type everything in. Now, the main thing here is whenever I type everything in is that I have to make sure that whenever I do this that I am in degree mode. So I have to go into my mode, make sure that degree is highlighted. If you're dealing with a scientific calculator, you need to make sure that it says DEG at the top and not RAD. Okay, it shouldn't be in radian mode. So I need to make sure first that I'm in degree mode before I do anything, and then it just becomes, like I said, just typing everything straight in. So I'm going to have 10.5 times tangent of 34.5. Close the parenthesis and hit enter. I'm going to round it to to 1 decimal place, so I'm just going to say it's going to be 7.2 as far as my length. So whenever I go back to my So I go back to my length and I have A is equal to, we'll just say 7.2. Now, again, I still need to find my hypotenuse. Okay? I am not going to use 7.2. The only two values I should ever use in finding anything are the two values that are given. Okay? Do not use the 7.2. Do not use a value that I just got. Okay? If you do, it's going to give you an answer that is using an estimated value and not an exact value, which then in turn is going to give you a wrong answer for C. Okay? You may not think it's a big deal, but you will think it's a big deal whenever I look at your answer and say, nope, that's not right. You didn't do what you were supposed to, and you get it wrong because you were too lazy to do it the right way. So then, if I have C, again, C was the hypotenuse, 10.5 was the adjacent side, which of my three trig functions am I going to use? Sine, cosine, or tangent? Cosine, right? So I'm going to have cosine of 34.5 degrees equals adjacent, which is 10.5, over C. Now, we could do the long version of this, and we could multiply both sides by C and have C times cosine of 34.5, and then have to divide everything by cosine of 34.5 degrees. The shortcut to this is, if you have to find a value and it's in the denominator spot down here, if your variable is in the denominator spot, then all you have to do is take whatever's on the left side and your denominator and switch places. So I can just go C equals 10.5. It didn't change. It did not change places. 10.5 is still in the same spot. Instead of it being divided by c, it's going to be divided by cosine of 34.5 degrees. I have the variable on one side. I have everything else on the other. I go to my calculator. I'm still in degree mode. That hasn't changed. And I type in 10.5 divided by, I would normally put this in parentheses just to make sure, depending on the calculator, of cosine of 34.5. Close both of them. Hit enter. My hypotenuse is 12.74, so if we round it to the 10th place, it would be 12.7. So my value so we had 7.2. We had 7.2 here, and then now we have 12.7. On ones like 2, the biggest thing again, you don't necessarily always have a right triangle that sits on your line. Okay? It may not sit on the right triangle side, so you've got to pay attention. You've got to basically find the box or find the right angle, because what is x? Is it opposite, adjacent, or hypotenuse? It's hypotenuse, because it's across from the right angle. Well, you're too busy making your soccer supporter wristband a rubber band and shooting it at Caden. That was the beginning. So you're given an angle of 59 degrees. The hypotenuse is x. What I would suggest is always figuring out, like if you're given 59 degrees as far as your angle, go ahead and write, even if we don't have to find every side, write down what's opposite, what's adjacent, and what's hypotenuse. Okay? At least find the opposite side, because if you should always be able to find the hypotenuse of any triangle, because it's always going to be the one across from the 90-degree angle. Okay, so if you can find the hypotenuse, you can automatically, or should be able to find the opposite side, because it is across from your angle. And then that means that you're left over with your adjacent side. If you struggle figuring out which ones, especially the adjacent side, okay, find the hypotenuse first, figure out which angle you have, and the opposite side is going to be the one across from it. Okay, if you have to draw a little arrow every single time, you're like, boom, that's opposite. Okay, the only thing that's left is adjacent. Okay, you solve everything the same way. So if you're trying to find the hypotenuse, you're given the adjacent, are you going to use sine, cosine, or tangent? Which one? Cosine. So I'm going to use cosine of 59 degrees equal to, adjacent side is 34 over x. Now, x, or my hypotenuse, is in the bottom side, so what do I need to do with the x and the cosine of 59? Swap places. So, cosine of 59 degrees is on the bottom, 34 is still on top. I'm going to go to my calculator, and I'm going to type in 34 divided by cosine of 59 degrees and get 66.0 as far as my side length is concerned. So x is equal to 66. In some cases, you'll be given pictures, and then it'll ask you to find certain things, like maybe the height of a tower. Everything is going to be a 90-degree angle for right now. Okay? In some cases, you may not have a picture. Hey, it may just tell you from a point on level ground 80 feet from the base of the Eiffel Tower. Angle of elevation is 85.4 degrees. Approximate the height. Okay. If you don't have a picture, I would suggest drawing a picture. Okay. It's a lot easier, I feel like, for students to do that. 3 and 4 are going to be similar to how we've already solved these. Because we're up against time constraints, we're just going to go ahead and go to 5. Okay, because it's going to be a little bit different. So in this case, you have, it says a kite flies at a height of 30 feet when 65 feet of string is out. String is in a straight line. Find the angle that it makes with the ground. Unless it tells you that you are 6 feet tall and you're holding it 6 feet above the ground. Okay? You just assume that it's going from the kite straight to the ground. It's like a stake in the ground, has the string, and then the kite's just flying with nobody holding. Okay? Again, unless it tells you, don't assume and say, well, I'm 5.5 feet tall or I'm 6 feet tall, because then it's just going to mess with everything else. Okay? The angle's not going to change, but it could change because of how you're manipulating the values as far as your triangle is concerned. Okay, so again, I would draw some sort of picture. Okay, if you have a kite here and it's on a string down to the ground, and again, it's 30 feet off the ground. So I have a right angle here. The kite's 30 feet above the ground. The string is 65 feet. We're trying to figure out what this angle is down here in the corner. So you're given two sides, you're trying to find an angle. So it's a little bit different than what we've done before. Again, I would still try to figure out, or I would still write, what is everything? What is 30? Is 30 opposite, adjacent, or hypotenuse? It's opposite. What's the 65? It can't be opposite, so is it adjacent or is it hypotenuse? It's hypotenuse because it's across from the right angle. So then, we have to go with our right triangle trig. Which one is using opposite and hypotenuse? Sine, cosine, or tangent? Sine. So it's going to be sine of theta is equal to 30 over 65. So anytime you are having to solve for an angle, all you're going to do is you're going to replace, you're going to flip just like we did when we had a value or a variable in the denominator spot. Same thing if you were trying to find a degree measurement or an angle measurement. I'm going to take theta and I'm going to take the 30 divided by 65, and they are going to switch positions. Now, whenever I do that, I'm going to make it inverse sine of 30 over 65 is going to give me my angle measurement. So instead of typing in sine of 30 divided by 65, it's going to be inverse or arc sine, whatever you want to call it. I go to my calculator. I hit second, sine, 30 divided by 65. Close the parenthesis and hit enter. About 27 it said round to the nearest tenth, so 27.5 degrees. Again, I would draw a picture. It'll make things a lot easier for you, because that way then you can see and you can actually write out what you have.